Hello everyone, welcome back to the Proactive Learning YouTube channel. Today we're gonna go through question 10, paper 2 from the June 2019 A-level maths series. So this is one of the most difficult vector questions that Edexcel has put in a past paper. So this is definitely towards the A star tier when it comes to difficulty. So let's see what the question is about. So we're given a triangle OAB and we're told the following. We're told that O to C is two lots of O to A. So let's try and actually draw what C is to start us off. So O to A is this green line here. So what's two lots of this green line in this direction? It's just this, isn't it? So in other words, we can create our point C here. But now let's remove this and continue reading the question. So then we're told the point M is the midpoint of AB. So let's go at the middle of AB and let's label it point M. And from here, we're also told that the straight line through C and M cuts OB at the point N. So let's draw a straight line from C to M and see where it ends up on OB. So it's going to look something like that. So then this would be our point N here. Now we're told O to A is A and O to B is lowercase b. Now, since we have the point N, I'll just write B here. So we still know O to B is lowercase b, but we're just going to make sure our diagram is nice and simple for us to look at. So part A says, find C to M in terms of A to B. So the first thing that we want to look at when it comes to vectors is what path can we take? So we're going to go from C and we're going to go to M here. Now, what different ways can we do this? Now, one way we could do it is just by going back here and then going that way. So in other words, what we can write is C to M is equal to, now in this case, remember, O to C is two lots of O to A. So in other words, A to C is just A as well. So in this case, C to M is equal to negative A to C. Then we're going to add A to M, aren't we? So here, negative A to C is just minus A. And then A to M, remember, M is the midpoint, so it would be half of A to B. So now, what is A to B? If we have a look back at our triangle here, A to B is just the path from here all the way to here. So what does this mean? So A to B, we have to go minus A, then we have to add B, don't we? So if we substitute this in, what do we get? We get minus A plus half. Then in brackets, we've got minus A plus B. Now let's expand out these brackets and simplify. So we have minus A, then we have a half times by minus A. So we have minus a half lots of A. Then we're going to add half of B. And once we simplify this, we get negative 3 over 2 lots of A, add half of B. So that is what C to M would equal. So that's part A all done. Now, let's have a look at part B now. So part B is the main bit that's really tricky, that a lot of students sort of got stuck on. So let's read it and see what we need to do. So we're told to show that O to N is this expression here, where we have some sort of scalar constant. So when it comes to show questions, the first thing we want to look at is understand what we're trying to find. So we're trying to find O to N. Now, if we look at what O to N actually looks like, O to N is just this area here, isn't it? From O to N. So just like we did for part A, what sort of route could we take to go from O to N? Now, we don't know what the ratio or where N intersects O to B, so let's use a different path. Let's say, for example, we want to look at the following way of getting to O to N. Let's say we go from O to A, then we go from A to C, but then a neat trick we can use here is, since C to N is a straight line, in other words, C to N is a scalar multiple of C to M. So I'll repeat it one more time. Since C to N is a straight line, what we can say is C to N is a scalar multiple of C to M. So in that case, one way we could write this is we can say, for part B, O to N is equal to, now in this case, we want to go 2 lots of A up to go from O to C. So what we would then do is we have 2A. Then we're going to add, now for the scalar multiple, we want to include this expression here. So we put the scalar multiple of, then in this case, we want to put C to M, don't we? Now, have we done any work in part A that's made our life a lot easier here? We have, haven't we? We've already found out what C to M actually is. So we can substitute that in, can't we? So in that case, we have 2A plus our scalar multiple. Then, instead of writing C to M, we'll write minus 3 over 2 lots of A, add half lots of B. And from here, if we expand our brackets out and simplify it, let's see what we get. So we have 2A, then we have minus 3 over 2 lambda lots of A. Then we have plus a half our scalar multiple, lots of B. Now here, let's see if we have any sort of common variables. Now 2 of our terms have A in them, so we can take a factor of A out. Then we're left with 2 minus 3 over 2 lots of our scalar multiple. Then we're going to add half lots of our scalar multiple, B. Now, is that exactly what we wanted to show? It is, isn't it? So that would be part B all done. From here, part C is quite tricky as well. But once we've done part B, there's a useful thing we can use from part B. Now, something also to bear in mind, you don't need to fully or correctly answer part B to do part C, because the question or the examiner has told you exactly what you wanted to show. So in other words, you've got the start of part C already given in the question. Now, part C says, prove that O to N in a ratio with N to B is equal to 2 to 1. So let's write out the ratio and see what we need to find. So O to N in a ratio with N to B, that is equal to 2 to 1. Now, we have these two vectors, O to N and N to B. So let's have a look at them on our diagram. Now, O to N is this purple one here, and then N to B is this red one here. So if we have a look at O to N, part B said, show that O to N is this. Now, one thing that's stopping us here is we don't know what this scalar constant actually is. So could we find that out? Now, if we look back up at a triangle, to go from O to N, it's some multiple of B, isn't it? Because we're not moving up, we're not moving anywhere other than in the B direction, right? So if we have a look at our O to N expression, what we can say is the coefficient of A has to be 0, surely, because we're not moving in any other direction except for some multiple of B. So in that case, what is the coefficient of A? The coefficient of A is 2 minus 3 over 2 lots of our multiple, scalar multiple, and that is equal to 0. So if we do some rearranging, we get 3 over 2 lots of our scalar multiple, that is equal to 2, then our scalar is equal to 2 times by 2 over 3, and that is equal to 4 over 3. So from here, what we can then think about is, okay, now that we've figured what our unknown is, let's find out what multiple of B we need to get from O to N. So to do that, that would be a half lot of our scalar constant B. So we would have a half multiplied by 4 over 3 lots of B. And that is equal to 4 over 6, which is the same as, or 4 over 6 lots of B, which is the same as 2 over 3 lots of B. So in that case, what we now know is we know O to N is equal to 2 over 3 lots of B. But remember here, to go from O to B, that's just one lot of B. So we can now include the following. So O to N is 2 over 3 lots of B. So to get to one lot of B, all we have to do is add a third lot of B. to go from n to b. So from here, what we can now do is say, okay, O to n in a ratio with n to b. Now we can write down what each of the actual vectors are. So O to n is 2 over 3 lots of b, and then n to b is a third lot of b. Now in this case, if we times both sides by 3, we can then get the ratio 2 to 1. Now is that what we wanted to show in part C? That's exactly what we wanted to show in part C, the ratio of 2 to 1, which we've shown up here. And that would be question 10 from paper 2, June 2019. So this is quite a tricky question, but the main sort of trick that we need to understand here is when we have points on a straight line, to go from one point on the line, such as M, to a point somewhere else on the line, N, all you have to think is this must be a scalar multiple of a vector that I know that is on the line. So hopefully that answered some questions you guys had. Hopefully with some more practice, these harder vector questions will become a lot easier. Feel free to drop in the comments any other type of A-level questions from past papers that you want me to work through and show the solution to. And with that, please like, comment, and subscribe. That will be it for today's video. See ya.